Hi, this is Sami again. Today we're gonna do factoring difference of squares. So factoring a difference of squares. There are so many questions that you could get in this section, and some of them are a little bit challenging. We'll try to make them easy in this lesson. Also, at the end of this lesson, I will introduce you to factoring trinomials. And as a matter of fact, we're gonna do a mix of a trinomial with a difference of squares. And at the end, just look out for the link to all the chapter about factoring. So that will be from starting to end the whole chapter of factoring as greatest common factor, and also difference of squares, factoring trinomials, and so on. Okay, so that link will be at the end. Just check it out on top there, and you'll see it. All right, so let's go and start explaining the difference of squares. So I think first thing that we need to know when we're factoring the difference of squares is understanding how to recognize that we need to factor using the difference of squares. How do we recognize that? It's always a binomial. So whenever you have a binomial means two terms. So if you look here and here, you have two terms. Here you have two terms. Here you have two terms. And all of these, you have two terms. And the sign in the middle between the two terms is negative. And also, this has to be a perfect square, and this has to be a perfect square. Once you have that, or you have those conditions, then it's so easy to do. All you need to do is just open two sets of brackets. Okay. Put a negative in the middle of one bracket and a positive in the middle of the second bracket. Doesn't matter if you put the positive here and the negative here, as long as one of them is negative and one of them is positive. So x squared minus 49. Now you go to the x squared and say, what's the square root of x squared? The square root of x squared is x. So you put an x here and an x there. And then you look at the number 49 and you ask yourself, what's the square root of 49? Square root of 49 is 7. So you stick a 7 here and you stick a 7 in the second bracket. And that's as simple as it is. Factoring the difference of squares is very simple. That's what you do. Okay. So let's do this here. As I said, 1 plus, 1 minus in the middle of the bracket, two brackets. Now, the square root of 4b squared, the square root of 4 and the square root the b squared. So square root of 4 is 2, and square root of b squared is b. So they are together, they stay together. So 2b here and 2b here. And then the square root of 121 is 11. You put 11 here and 11 there. How about this one? We apply the same thing. One is negative, one is plus. Now the square root of 121 m squared, the square root of 121 is 11, and the square root of m squared is just m. And we write that in both brackets at the beginning, or at the start of both brackets. And then the square root of 100 n squared is 10n, and that's what you have right here. Okay. Now we get to question number 5. And when we look at this, this doesn't meet the conditions that we said about these here, where both of these have to be perfect squares. All the other conditions are met, but these here are perfect squares, but here they are not. The 20 and the 5 are not perfect squares. Now we go back to what we learned at the start of factoring. And what we learned at the start of factoring is the GCF, the greatest common factor. What's the greatest common factor here between 20 and 5? It's 5. So I take out 5 as the greatest common factor, and then I'm going to get 20 divided by 5 is 4. X squared, and 5 divided by 5 is 1. So we don't even have to write the 1, and you have y squared. Do we stop here? Definitely not. We're going to continue, carry on. I don't know why I wrote a 4. Carry on the 5 and open two set of brackets, because now this here follows or meets all the conditions for factoring the difference of squares, like here. So the square root of 4x squared is 2x. So you put 2x here and 2x there. Again, you make 1 minus, 1 plus, And the square root of y squared is y. So you get y here and y there. The same here. We got to take out the greatest common factor first. So the greatest common factor between 18 and 50, 2 would be the greatest common factor. But also we said if we have variables that exist in both terms, we have to take one of them out as the greatest common factor, and you take the one with the lowest exponent out. So y squared is the lower exponent than y to the 4. So we take y squared out. Now we divide 18 by 2, we get 9, and we have the x squared, and y squared by y squared, when you divide them, they cancel, so we don't have a y squared in the first term anymore. And then 50 divided by 2 is 25, and y to the 4 divided by y squared gives me y squared. Now see, this wasn't a perfect square, and this wasn't a perfect square. Now once we take out the greatest common factor, then this right here end up meeting the conditions for factoring a difference of squares. So we put a 2y squared there, we carry that. And here we open two set of brackets. 1 minus, 1 plus. The square root of 9x squared is 3x. Put that here and there. And the square root of 25y squared is 5y. We put that here and here. And we're done with the first page. Now let's go to the second page. Now this one here, can we factor this using the difference of squares? Look at it for a second here and tell me if we can factor it using the difference of squares. Some of you, you're going to look at the fraction and say, oh my God, how am I going to do it with fractions? Same thing. You put a minus in one, plus in one. Take this square root of 25m squared, which is 5m. You put this here and this here. And take the square root of 1/4 n squared. Well, the n squared will give me n, but some students struggle taking the square root of a fraction. Well, when you take a square root of a fraction, all you need to do is just take the square root of the top, which is 1, and square root of 1 is 1. So you put 1 here, 1 there. And the square root of 4 is 2. So you're going to have 1 over 2, 1 over 2. So basically, the square root of 1/4 is 1/2. So that's what you do. So it's basically, that is what the factoring of something that has fractions is. So it's looks hard, but it's very simple once you break it down. Now, how about here? Here we have two perfect squares. So it meets all the conditions. The square root of x squared is x. The square root of 49 is 7. Of course, has to go on the bottom. So x over 7 in both brackets. Make 1 plus, 1 minus. Give a little bit of space here. And the square root of y squared is y. Square root of 64 is 8. And the 8, of course, goes on the bottom because it was on the bottom here or on the denominator. So that is as simple as it is factoring these kind of questions. How about here? Here, we don't have, or we don't meet the conditions because we don't have perfect squares. However, we're going to take out the greatest common factor, which is 5. And then I'm going to get x to the 4 minus 16, because 80 divided by 5 is 16. And now we meet the difference, or we meet the conditions for the difference of squares. So we're going to carry the 5, and this factors into x squared plus 2 plus 4, sorry, plus 4, because the square root of 16 is 4. And of course, the square root of x to the 4 is x squared. And now we have x squared minus 4. Does this finish yet? No, it doesn't, because we still have the condition for the difference of squares right here. Do we have it here? No, we don't. Yes, that's a perfect square. That's a perfect square. But when it's a plus, you cannot do it. You cannot do the difference of squares if the middle sign is plus. But this meets the conditions for the difference of squares because it's minus. So therefore, we carry everything. So we carried x squared plus 4 as well. But x squared minus 4, we could factor that into x minus 2, x plus 2. Now here, this is where some students do struggle because now they don't see it. They don't see what's going on here. we always dealt with just perfect squares. We don't have an expression or a binomial inside the brackets or anything like that in all of the previous ones. But here you have a binomial inside the brackets. Well, this binomial here, without the square, it wouldn't be a perfect square. But this square here, anything that has a square on it, it becomes a perfect square. So what do we do? What we do is we open two set of brackets. We apply the same thing here. Like what we're going to write at the beginning of the brackets is the square root of this. And the end of the brackets is the square root of this. So we have two terms. We have this and this. Again, this is still two terms because this is inside brackets. It makes this two terms. This is one term and this is the second term. So as far as the 9, we know we're going to have a 3 here and a 3 there. How about, and we're going to make 1 plus 1 minus. How about this? The square root of this, when you square root x plus 2 squared, all that happens is the square root cancels the square. So I'm left with x plus 2, and that what goes here and goes there. And therefore, we're going to end up with x plus 5 because you still have to collect like terms on one side here. And here we're going to have x minus 1. And that's how you do these kind of questions. Here, is this any difference from this? This definitely meets the conditions for difference of squares. Two terms. This bracket is one term and this bracket is a second term. The sign in the middle is minus, so we definitely can do factor this. I'm going to put square brackets here and you'll see why we need square brackets at the beginning. Make 1 minus, 1 plus, okay. So what I'm going to put here is the square root of this. When you square root of this, the square root cancels the square. So I'm going to end up with 2x minus 1. And that's what I put here and put there. And the square root of this, the square is going to cancel. So I'm going to put brackets 7x plus 4. And why do I put brackets here? Because of the minus sign here. When it's a plus, you don't even need to write brackets. So you could just write 7x plus 4. And now some of you will ask why. Why when it's minus, we put brackets, and when it's plus, we don't put brackets. Because as we learned before, when you have a negative, it's a sign changer. It's going to change the sign inside here. But when it's a plus, it doesn't change the sign. So even if you put the brackets, nothing is going to change. So there's no need for the brackets here, but there's a need for the brackets here. So therefore, we have 2x minus 1 minus 7x minus 4, because we said the negative is a sign changer. Here, you could just start collecting like terms. 2x plus 7x is 9x. Negative 1 plus 4 is plus 3. How about here? 2x minus 7x is negative 5x. And negative 1 minus 4 is negative 5. Stick to the square brackets. Now, believe it or not, we don't stop here. And the reason we don't stop here is because we have a greatest common factor in here, which is negative 5. And we have a greatest common factor here, which is 3. So it's going to be negative 5. I'm just going to change the brackets to round brackets. If you factor out negative 5 here, negative 5 divided by negative 5 is 1. And so it's 1x. And negative 5 divided by negative 5 is positive 1. So this becomes x plus 1 times, we factor out the 3 from here, and we're going to get 3x plus 1. Now multiply the 3 and the negative 5, you're going to get negative 15. So this is a bit long. And we're going to have x plus 1 and 3x plus 1. And that's the end of this question. So this is a bit long, isn't it? But, you know, it's good to know how to do it, and always look for the greatest common factor, or look out for the greatest common factor when you have a final answer like this. If there's a greatest common factor and you don't take it out, you lose a little bit of a mark if you're writing a test. Now, the third slide, which is this one. This third slide here, I'm introducing you to factoring a trinomial. So this here, the first one, is going to be just factoring trinomials. But the second one, it's going to be factoring trinomials, and then this is going to lead us to the difference of squares, and you'll see how that works, okay? So here I'm going to factor this, and to factor a trinomial, it's not as easy as factoring difference of squares, because in this one here, what you do, you look for two numbers that multiply to give you the negative 15, multiply to give you the constant. So two numbers multiply to give you negative 15. And these two numbers, when you add them, they should give you the number in the middle, which is negative 2. The two numbers here are going to be negative 5 and 3, because 3 times negative 5 will give you negative 15. And negative 5 plus 3 will give you negative 2. So therefore, now this, you have an x here, an x there, and it's going to be minus 5 plus 3, because negative 5 times 3 gives you negative 15, and negative 5 plus 3 will give you negative 2. So we're going to apply the same thing here at the beginning. So we have y to the 4. If it's y to the 4, then we're going to have a y squared here. Okay, at the beginning of each bracket, y squared, y squared. Now we're looking for two numbers that multiply to give me positive 16 and add to give me negative 17. So the two numbers here are going to be negative 16 times negative 1, because negative 16 times negative 1 will give me positive 16, and when you add them, you get negative 16. It's negative 17, sorry. So it's negative 16 and negative 1. That's what multiplies to give me positive 16 and add to give me negative 17. Now, do we stop here? Definitely not, because now if you look at this brackets and this brackets, both of them have the difference of two squares inside them. So this here will factor into y minus 4, y plus 4, and this one will factor into y minus 1 and y plus 1. And I think that's all that you have to worry about in factoring the difference of squares. If you understand how to do all these questions, you shouldn't be stuck on any question as far as the difference of squares matter. And here it is. It's the end of factoring the difference of squares. Still, we're going to continue with grade 10 math till we finish the whole curriculum. And I hope students in Canada are benefiting from this. Don't forget to hit that like button and comment when you can. But most importantly, subscribe to my channel. Your support goes a long way. Keep on supporting. As always, thank you for watching. And don't forget to check out the link on the top there. It's the 31st of December. So happy New Year to all of you. Prosperous 2023.